Hi, I'm Shane Bradley. This little video is just going to give you a bit of a demonstration about what I've learnt in systems and structures, some of my key takeaways and some of the things that I found the most interesting. Some of my key takeaways were definitely getting a better understanding of how tension and compression work. For example, when you apply a compressive force on the top of a structure, you'll see that it begins to fail at its weakest point. Moving on from this, I did take some inspiration from Eames, who designed a chair with this similar structure here as the legs of its chair. And I found this quite interesting because when forces are applied to the top of it, the four outside pieces are under compression, and without any support, you'd see that they begin to bend, and with too much force, they begin to fail. So this is countered by different beams inside that are under tension. So as this piece tries to pull out, the ones on the inside are under tension, keeping them in, holding the whole thing stable and in equilibrium. So a quick little demonstration on when forces are applied to this one. Okay, I'm going to start off with just 4 batteries. 2 more. And you'll see that 6 batteries is just about its tipping point. And in 1 more, you'll see it begins to rotate upon itself, a torsional force, and begins to fail with time. There we are. So that was 8 batteries of force applied to it. So I took this similar idea and I actually then began exploring some different cantilevers because that was my next interest. So I've got one cantilever style design here. This is the first one that I made, and I took inspiration from one of the tutorial projects for this one. And you'll see that when built in 3D, this would be able to hold itself. And I found it quite interesting because the torsion or the tensile cables hold the force. So as this tries to rotate downwards at the end here, the cable keeps it in equilibrium. I also explored a few different bridge ideas. So I've got one here where we have some cross bracing underneath, and then you've got 2 pieces of bracing along the middle. And when placed as a bridge with some structure underneath it, you'll notice that as force is applied, it will surprisingly hold a lot of weight before it begins to fail. There we are, so you can see that's holding 8 batteries worth of weight on that small little bridge there. Alright, so from this I moved into my final design. I wanted to compile a few of these different ideas. So I've taken the cantilever idea and I've taken this cross bracing idea, and I've formed my final project, which was a stadium, which is this one right here. So you can see that the 2 outside parts are being held by tensile cables, and as forces applied, in the same respect as the cantilever here, as forces applied to the outside, the tensile cables hold it in place at both ends. I've then taken inspiration from the bridge design I built and the different truss designs from the Eames chair. So I've created trusses inspired by the Eames chair, and then I've taken different cross bracing from the base of the bridge to wrap around to create the stadium, which ended up in a circular structure. From here, I decided to build upon this idea and to see whether I could actually create different platforms for the stadium. So as I placed different flooring from balsa wood, there we are. Yeah. I noticed that this was quite an interesting design actually, because it was able to hold a surprising amount of weight, and I'm not going to break it in this video today, but I will in class. It ended up holding up to 12 batteries before I remade it at one end. I then built upon this idea. I developed my trusses a little bit more and where the tensile cables or the tensile string was sitting. In my first practice example, I had the string sitting a lot closer to the axis point, which wasn't able to hold much weight. Now that I have it moved further away from the axis point, which creates greater distance, I'm able to hold more weight. So this example here held, I think it was 30 batteries before it began to fail. And I'm going to continue building on this idea, and hopefully it'll be able to hold more than that in the next class demonstration. Thank you for your time.